In this video, we are building a professional smart gas and smoke detector from scratch using the ESP8266 microcontroller. Unlike ordinary alarms, this device connects to the internet, stores history, and detects threats instantly. Plus, it logs everything with atomic clock timestamps. Before jumping into this awesome DIY project, don't forget to subscribe, leave a like, and turn on notifications. Let's get started. Our first component is the Nodemcu ESP8266 development board. With this board, we can easily create IoT projects thanks to its built-in Wi-Fi connectivity. It processes sensor data and sends it directly to the internet using its powerful microcontroller. Our second component is the MQ gas sensor, specifically the MH series. This sensor detects smoke and harmful gases in the air with high sensitivity. It converts air changes into an electrical signal Nodemcu can read. This makes it ideal for fast and reliable gas and smoke detection systems. Our third component is the passive buzzer, which is used for sound alerts. Unlike active ones, it needs a Nodemcu signal to change tones, allowing us to create clear and effective alarms when gas or smoke is detected. We are also using a 5mm red LED and a 220 ohm resistor. When the alarm goes off, this red LED will light up to provide a visual warning. The resistor will protect our LED from high current damage. Our next component is the push button. We will use this button to easily navigate through the menu. The components that will bring our entire project together are this double-sided prototype PCB and the pin header connectors. By placing all the components onto this solid board, we eliminate circuit clutter and give our project a truly professional, clean hardware structure. Now that we've introduced all the components, let's jump straight into the build process. We've finally assembled all the components successfully. Now we plug the USB-C cable into our Nodemcu board and connect it to the computer. It's time to upload our powerful firmware. We will use the Arduino IDE to compile the project. All the source codes for this project are available on my GitHub repository. If you want to build it too, you can download them directly from there. Now let's move on to uploading our code. After loading the code into the Arduino IDE, the first thing we will do is find the Wi-Fi configuration lines right at the top and enter our own wireless network credentials. Now let's open the File menu and click on Preferences. For Arduino IDE to recognize our board, we simply paste the ESP8266 library link into the Additional Boards Manager field as you see on the screen and hit OK. From here, we click on the Boards Manager icon on the left side. After typing ESP8266 in the search bar, we normally press the Install button. As you can see, I've already installed it before. I don't want to extend the video with installation steps. Right after that, we go to the Library Manager icon on the left and type Adafruit GFX in the search box. Normally we click Install, but as you can see, to keep the video short, I have already installed this one beforehand as well. As you can see, we first check the port under the Tools menu and make sure that the COM6 port, which also appears in the bottom right corner, is selected. Once we confirm the ESP is connected, we go to the same menu and set the flash size option to exactly 2 megabytes OTA, just as shown. We start the upload by clicking the arrow button in the top left. Our code is now compiling and transferring to the board. Just a quick note, there is a detailed step-by-step installation guide available on GitHub for your reference. I sped up this part of the video because I don't want to drag it out. And as you can see, everything has been loaded smoothly and correctly. Let's test the device now. The device has started running and is establishing the Wi-Fi connection. Right after that, it switches to the System Ready screen. And finally, it's up. You can see the time, date, and air quality information right on the screen. Let's test the push button now. And as you can see, navigating through the menus works perfectly on the screen. As you can see, I hold the lighter to the sensor and release some gas. The device works perfectly, the buzzer beeps, and the red LED flashes. And that brings us to the end of another video. To show your support, please don't forget to subscribe to my channel, leave a like, and drop a comment below. Your support truly means a lot to me. See you in the next video.